And finally, we're going to look at our mass problems, which would also be the same for anything that I would call a mixed problem. Mass, of course, is going from grams to grams, but we would have to go through the same process if we were going from grams to liters, or liters to grams, liters to molecules, grams to molecules. As long as it's not from the same thing to the same thing, we would have to do the like process. So, again, 3 steps. Step 1 is go to moles. Step 2, mole ratio. And step 3, go to desired units. Now, in this case, we're talking about mass. Okay, and if we're going to have mass in terms of step 1, go to moles, then I need to use the periodic table to figure out what the molar mass, gram formula mass is of whatever it is I want to change. So I've got 61.5 grams of potassium chlorate. So there's my 61.5. And I want to know how much potassium chloride, how many grams of that. So there's my question mark. So when I get there, I can see that my mole ratio will be 2 to 2. So essentially, the moles won't change. All right, potassium chlorate. Have to look up on the periodic table for KClO3. I would have, well, the potassium, basically it's 39. The chlorine, 35. And 3 times 16 for the oxygens. So that adds up to 122 grams. That's the molar mass, or gram formula mass. So, step 1, go to moles. .5 grams times 1 mole per 122. Now, that's also, if I put in all of the decimal parts, you'd get pretty close to 123, but we'll just leave it at the 122 grams. Comes out 0.504 moles. And this is of the KClO3. And again, putting this part here just helps you keep it straight. Now, step 2, mole ratio. Okay, well, mole ratio will be my 0.504 moles times, in this case, 2 over 2. 2 in front of the KCl, my question mark. 2 in front of the KClO3. And of course 2 over 2 is just 1, so this is going to be 0.504 moles of my KCl. And then step 3, because these are mass problems, I want to go to grams. So I'm going to take my 0.504 moles. And now for KCl, that would just be the 39 and the 35, which is 74 grams per 1 mole. And I get 37.3 grams of KCl. So, had to do all 3 steps. And the steps always look like this. Go to moles, where I essentially did a divide here. Use my mole ratio. Go to grams, where I did essentially a multiply with the grams on top. So every single mass problem will look like this. Mixed problems will look very similar, but if I had started in liters, then my first part would have been divided by the 22.4 instead. Yes? Again, the 74 grams comes from KCl. So the K, as we set up here, was 39. The Cl is 35. So there's my 74. Any other questions on this one? A little bit more work. Okay, let's look at a second one. How many grams of hydrogen, here's my question mark, are necessary to completely react with 56 grams of nitrogen? 56 grams of nitrogen in the above reaction. So again, step 1, go to moles. So 56 grams times 1 mole over, well, we're looking at nitrogen here, N2 to be precise. Nitrogen is a mass of 14, so 2 of them would be 28 grams. Again, N2, 2 times 14 gives me the 28. So 56 over 28, 2 moles. Step 2, mole ratio, 2 moles times 3 over 1 gives me 6 moles. And this is why I say sometimes labeling can kind of help you. Here I have 2 moles, there I have 6 moles, but they're not of the same thing. This 2 moles, that was of the nitrogen. This 6 moles, that's of the hydrogen. So simply putting that down just kind of keeps straight what it is I'm doing, because you can, kind of get confused at times. And then, again, we want to go to grams. So we're going to take our 6 moles times, well, we're looking at H2 now, so of course H2 is just 2 times 1, or 2 grams. Moles, of course, will cancel. 6 times 2, I get 12 grams of hydrogen. Now, problem 3 says how many grams of ammonia are produced in the reaction in problem 2. Now, I already have problem 2 done, so I already have step 1 done. That was to go to moles to give me 2 moles of nitrogen, so I don't need to redo that. But what will change is now that I'm doing my mole ratio step, I have a new mole ratio. It's going to be 2 moles times 2 over 1, because again I've switched the question mark to over here now, so that has to be what's on top. Where'd the 2 moles come from? It came from doing step 1 in the previous problem. That part didn't change. It's still 56 grams turned into moles. So 4 moles of NH3. And again, just a reminder, step 1 already done above. Now, new step 3 would be go to grams, 4 moles times 17 grams per 1 mole, 68 grams. And this is of NH3. And again, where the 17 came from? NH3, 1 nitrogen plus 3 from the 3 hydrogens. That gives me my 17. Any questions? Okay, number 4, how many grams of silver chloride, AgCl, so here's my question mark, are produced from 17 grams of silver nitrate? So there's what I've already know. With excess barium chloride, I have all the barium chloride I need. So obviously I'm going to need some molar masses here, so let's work off of the AgNO3 first. AgNO3, silver, that's going to be basically 108. 1 nitrogen, so that's 14. And the 3 oxygens, another 48. So that's 170 grams. And when we get to the AgCl, later on, that'll be 108 plus, again, we can just say 35 for the chlorine. And so that one comes out to be 143 grams. Okay, step 1. Go to moles. 17 grams times 1 mole over 170 grams. .1 or 1/10 mole, 17 over 170. Step 2, mole ratio. 0.1 mole. Our mole ratio is again 2 to 2. So it's 0.1 mole. So this was of the AgNO3, and this is 0.1 mole of the AgCl. That's what I want to find out about. And then step 3, go to grams. 0.1 mole times 143 grams per mole, 14.3 grams. And then our final one, how much barium chloride is necessary to react with the silver nitrate in problem 4. So basically that's saying how much barium chloride do we need to use up that 17 grams. Let's see, barium is 137 plus 2 chlorines, which is essentially 71. Notice I call it 71 and not 70, because if you look up chlorine, chlorine is 35.453. So if I have 2 of them, doubling 35.45 would be 70.9, which is essentially 71. So these together are going to give me 208 grams. Now, again, this refers to problem 4, so I don't have to redo problem 1 here. Or excuse me, step 1, I can go right to step 2, the mole ratio. But I have a new mole ratio now because I'm looking at the barium chloride, and so it's going to be my 0.1 mole times 1 over 2, because there's nothing in front of the barium chloride, so that means a 1. 1 over 2. So that's 0.05 moles. And then now we're going to go to grams. .05 moles times 208 grams per mole. .4 grams. So that's doing stoichiometry problems, and the only ones we really didn't do but would be very, very similar to this page here is what if the units changed. So what if we started in liters and wanted grams at the end, or what if we started in molecules and wanted liters? It would just change steps 1 and 3 from the sense of step 1 still be go to moles, but instead of dividing by the molar mass, I would say divide by 22.4 because I was in liters. Or I would divide by 6 times 10 to the 23rd because I was doing molecules or formula units. And then, of course, step 3 would mirror that. If I didn't want an answer in mass and grams, but I wanted an answer in liters, then the third step would have been times 22.4. So I can start in grams and end up in liters, if that's what I wanted to do in the problem. Any questions? Okay, so pretty much that is what's going to be done for our stoichiometry.